So for problem number 15, they're giving us f be the function defined above, and this is a piecewise function. And they're asking which of the following statements about f are true. So we need to take a look at the one-sided limits for f. So we need to take a look at, okay, so what's the limit as x approaches 1 from the left of f of x? So to calculate this one, because we're saying to the left of 1, that would be x is less than 1, we need to plug do a direct substitution with 1 into this function, because that's where x's are less than 1 or to the left of 1. So this would be 3 times 1 minus 2. So that'd be 3 minus 2, which would be 1. Okay. And then the limit as x approaches 1 from the right of f of x. And that would be, we're going to plug it into this one, and that would be the natural log of 3 times 1 minus 2. And that would be the natural log of 1. And the natural log of 1 is equal to the natural log of e to the 0. So that would mean this is equal to 0, because natural log of e to a power, they undo each other. All right, so these aren't the same. So that, okay, so that's telling us that there's a discontinuity, right? There's a jump discontinuity. At x equals 1, because the left one is 1 and the right one is 0. Okay, how about the derivative, the limit, the one-sided derivatives, right? So to find the derivative of a piecewise function, you know, f prime of x, it's going to equal, all right, the derivative of this piece, which would be 3 if x is less than 1. And then it'd be the derivative of the natural log of 3x minus 2 if x is greater than 1. And so this one would be 1 over 3x minus 2. We need to apply the chain rule. So the derivative of the inside function, which would be 3. So we need to multiply that by 3. And this would be if x is greater than 1. Okay, so then we could rewrite this if we had time. Okay, but I'm just going to go ahead and start plugging it in. All right, so we want to find the limit as x approaches 1 from the left of f prime of x. Well, we know that is 3. Okay, and the limit as x approaches 1 from the right of f prime of x, that's where we're going to plug 1 into this one. So that'd be, this would be 3 on top over, and then the bottom would be 3 times 1 minus 2. So that would give you 3 over 1, which is 3. So that's true. So this one is false, right? From before. This one we just figured out is true. True. There we go. Okay. And then we also need C. Is f differentiable? Well, what does it mean to be differentiable? That means, okay, it has to be continuous, right? F is not differentiable at x equals 1. Why? Because there's a discontinuity there, right? So f, we would say f is not differentiable at x equals 1 because f has a jump discontinuity at x equals 1. And so this one is false. So the only one that's true is statement 2, and that would be, the correct answer would be C. For number 16, the function f is defined by f of x is equal to this function 2x cubed minus 4x squared plus 1. Application of the mean value theorem to f on the interval 1 less than or equal to x less than or equal to 3 guarantees the existence of a value c where 1 is less than c less than 3 such that f prime of c equals. So you're guaranteed, right? This is going to work because of what they're saying here. And so what does the mean value theorem says? It says that the derivative at some c value between the endpoints, right, 1, 3, not including the endpoints, has to be the same as the average rate of change on that same interval. So what that means in symbols is f prime of c would have to equal f of 3 minus f of 1, because those are our endpoints, over 3 minus 1. So now it's just a matter of, okay, let's calculate f of 3 and f of 1. So f of 3 would be 2 times 3 cubed minus 4 times 3 squared plus the 1, and then minus, and then putting 1 in, that'd be 2 times 1 cubed minus 4 times 1 squared plus 1. Boy, there's a lot of arithmetic, huh? All over, and 3 minus 1. Okay, so 3 cubed, that'd be 27 times 2, that'd be 54. And then minus, and 3 squared is 9, times 4 is 36. So we got to subtract 36. Then we need to add the 1. And then minus, and then this would be 1 cubed times 2, which would be 2. And 1 squared, which would be 1 times 4. So that'd be minus 4, and then plus 1. All over, and then 3 minus 1 is just 2. So one thing is you could, actually I take that back. What I'm going to do is I'm going to go ahead and combine these. So 54 minus 36. Okay, so you may okay, how do you subtract in your head, right? So one thing you can do is called counting up. You could start at 36 and count up to 54. So that would be 18, positive 18, plus the 1. So that would give you 19 minus, and this is pretty easy to do in our head, 2 minus 4, that'd be negative 2, plus 1 is negative 1. So I'm going to subtract negative 1. That's still all over 2. And then this would be 19 plus 1, which is 20 over 2, and that gives you 10. So this is telling us that on this interval with this function, okay, there has to be a derivative that's equal to 10, right? And so that's the correct answer is C. For question 17, they give you the velocity v in meters per second of a certain type of wave is given by this function v of h is equal to 3 square roots of h, where h is the depth in meters of the water through which the wave moves. Okay, so the velocity, this is the velocity, it's in meters per second, okay? And then what is the rate of change? So here's the key. What is the rate of change of the velocity? So we want to find how is this velocity, what the rate, what's the change in it, right? So to find the rate of change of this, we got to take the derivative of it, right? So we're going to take the derivative of the velocity function. I'm going to first rewrite the velocity function. So v of h is equal to 3 square roots of h. It'd be easier if we wrote this as 3 h to the 1/2 power. And so we need to find v prime of h. And we're going to take the derivative, all right, of the wave with respect to the depth of the water. So we're taking the derivative with respect to h, okay? So when we apply the chain rule, we would have a dh over dh, okay? So this is equal to 3 times, and we're going to bring the power down. It's just the power rule, really. 1/2 h to the negative 1/2. And so this would become 3 times 1/2 times 1 over h to the 1/2, which would be the square root of h. So this would be 3 over 2 square roots of h. And then we want to find this velocity when the depth is 2 meters. So that'd be, we really want to find v prime of 2. So that'd be 3 over 2 square roots of 2. And the correct answer for this one would be C. Once again, 3 C's in a row. All right, let's go to the next one. So for number 18, if dy over dt is equal to negative 10 e to the negative t divided by 2 power, and y of 0 is equal to 20, what is the value of y of 6? So there's a couple ways you can do this. You can treat this as a differential equation, and this is the initial conditions, or initial condition. Plug that in, get your function, get that function, and then plug 6 into it. So that's one way to approach this problem. Another way is to realize, okay, this is the starting amount, and if I integrate from 0 to 6, so if I take that starting amount and I integrate from 0 to 6 this function, then I would wind up with the value of y of 6. Okay, so that's the approach that I'm going to take. All right, and so I'm going to take y of 6, this final amount. I know that's equal to the starting amount, which is 20, and then plus the integral. Okay, because if I multiply both sides by dt, I have dy. So if I integrate that, I'd have y. Okay, so I'm going to integrate this from 0 to 6, and then negative 10 e to the negative t over 2 power, and then dt. So I'm going to bring my negative 10 out. So this, I still have the 20, and then minus 10 times the integral from 0 to 6, e to the negative t over 2 power, and then dt. And then I'm going to do an integration by substitution. So I'm going to change this to u. So u would be negative t over 2, which is equivalent to negative 1/2 t. So then my du would be negative 1/2 dt. So this dt right here needs a negative 1/2. So I'm going to multiply this by negative 1/2, but I'm also going to multiply the outside by negative 2 to compensate for that. So this would be 20 plus 20, because negative 10 times negative 2 is positive 20. And then the integral from 0 to 6, e to the negative t over 2 power times negative 1/2 dt. So this becomes 20 plus 20, the integral from, and I'm going to hold off on writing these because I'm going to switch to my u's now. This is going to be e to the u du. And so now what I'm going to do is I'm going to switch the zeros to u values. Okay, so this is negative 1/2 times 0. That would just be 0. And 6 times negative 1/2 would be negative 3. Okay, and then this becomes y of 6 becomes 20 plus 20. And I'm not going to switch the order here. Okay, so and then so the antiderivative of this would be e to the u. And we're going to evaluate that from 0 to negative 3. So this would be 20 plus 20 e to the negative 3 minus e to the 0. So distributing the 20, that would be 20 plus 20 e to the negative 3. E to the 0 is 1, so this is 20 times negative 1, or negative 20. So that means y of 6 is equal to 20 e to the negative 3 power. And so the correct answer is B. So like I said, this is not the only way you could do this problem, okay? You could do separation of variable, well, not really separation of variables, but just you could treat this as a differential equation, and you'd get a function of y. Then you'd have to find your constant by plugging in 0 and 20 in for your t and your y. And then you'd have a function, and then you'd have to put the 6 in. I don't know which one's faster, okay? I think they both take a little bit of time, all right? Okay, let's go to the next problem. So for number 19, let f be the function with derivative defined by f prime of x is equal to x cubed minus 4x. At which of the following values of x does the graph of f have a point of inflection? So we know we have a point of inflection when the second derivative changes signs. So we are given the first derivative, we need to find the second derivative. So f double prime of x is equal to, so this would be 3x squared, and then minus 4. And then what we need to do is set that equal to 0. So 0 is equal to, we're finding the critical values here, 3x squared minus 4. Adding the 4, we get 4 is equal to 3x squared. That would mean 4/3 is equal to x squared. Square root both sides, and we get x is equal to plus or minus the square root of 4/3. So that means x is equal to plus or minus 2 square roots of 3. Okay. All right, so now we got to make our sign chart. Okay, so because we're gonna need to see, does the second derivative change signs at any place? Okay, so we're gonna go from negative infinity to this first x value, which is negative 2 over the square root of 3, and then negative 2 over the square root of 3 to 2 over the square root of 3, and then 2 over the square root of 3 to infinity. And then we're going to take a test point. So you want to, for this, I mean, sometimes it's hard for people to figure out what the value of this is, right? So what I'm going to do is I'm going to jump way over. So like, let's say this, there's no way this could be like negative 4. Okay. So that's what I'm going to use. I'm going to use x equals negative 4. Negative 4 has to be in here. Okay. A good one in here would be x equals 0. And over here, what's going to be bigger than this, right? And x equals 4 would definitely be bigger. Okay. All right. So if we plug this in, if we plug negative 4 into our second derivative, we would get 3 times negative 4 squared minus 4. And so this would be 16. That'd be 48 minus 4. All we really worry about is this is positive, right? That's definitely going to be positive. How about when we put 0 in here? Well, that'd be 3 times 0 squared minus 4. Well, that's going to be 0. So this one's going to be negative. So that means we have a point of inflection at x equals negative 2 over square root of 3. But you look, that's not one of our choices, right? So it's got to be, so it's going to have to be this one right here, right? Because it says we have at which of the following x values does a graph of f have a point of inflection. So if we put 4 into here, right, into the second derivative, that'd be 3 times 4 squared minus 4. That'd be 48 minus 4, right? So this is going to be positive. So yes, we have a point of inflection at 2 over the square root of 3. So the correct answer is C. So for number 20, let f be the function given by f of x is equal to, this is a quadratic, but actually numerator and denominator are both quadratics, right? If the line y equals b is a horizontal asymptote to the graph of f, then b equals. So basically, okay, so what we really need to do is expand this out, okay? So, and we're going to take I'm going to take the limit as x approaches infinity because that's how you find horizontal asymptotes, okay? So we're going to take the limit as x approaches infinity. That's what the definition of a horizontal asymptote is. That as x approaches infinity for our function, it's going to come out to be a number value. So in this case, all right, if we multiply this out, this is going to give us for a numerator 2x squared and minus 11x and then plus 12 over, and the denominator is x squared minus 2x plus 1. And all I did, you could use an area model to multiply these out, okay, if you need to. Now, when you have to look at the magnitude of this, right? So what's controlling the growth in the numerator? Well, it's this 2x squared, right? And what's controlling the growth in the x squared? All the rest of this is, when x is going to infinity, is really insignificant. So to determine this, we could take the limit as x approaches infinity of just the leading terms here. So 2x squared over x squared. That means that if we do this, the x squareds cancel, and this is going to be the limit as x approaches infinity of 2, which is just 2. Okay, so that means that our function has a horizontal asymptote at y equals 2, right? And so the b value would have to be 2. So that correct answer is C. So for 21, the base of a solid is the region bounded by the x-axis and the graph of y equals the square root. So we got to understand, like, what is this? Like, it's really good to know this is a semicircle. This is the equation of a semicircle, and it's the top half. And our x-intercepts are going to be at -1 and 1. Okay, so our graph looks something like this. So when you're not given the graph, it's kind of helpful to realize, okay, this is a semicircle. Because if I put -1 in here and square it, that's going to give me 0 for y, and also at 1. So it's centered at the origin, and so it looks something like this. Okay, And so the base of the solid is the region bound by the x-axis. Here's the x-axis. And the graph of y equals this, right? So for each solid, for the solid, each cross section perpendicular to the x-axis is a square. So our area function, remember area of a square is side times side or side squared. So what we're going to have to do is we're going to have to find this length right here, right? That's the side length that I'm talking about right here. Well, how do I calculate that, right? How do I find that? Well, it's the top minus the bottom. And the top is just this function right here. And the bottom is just 0. So my S is equal to the square root of 1 minus x squared minus 0, which is simply the square root of 1 minus x squared. That's the side length. So my area function would wind up being the square root of 1 minus x squared, which is simply 1 minus x squared. So now this point right here is -1 comma 0. This point right here is 1 comma 0. So then to find the volume, I'm going to have to integrate from -1 to 1. My area function times the thickness of it, which is going to wind up being dx. So that means this is going to be integral from -1 to 1 of 1 minus x squared and then dx. So that means the volume would be, this is going to be x minus x cubed over 3. And we're going to evaluate that from -1 to +1, which would give me 1 minus 1 cubed, which is 1 over 3. So minus 1/3. And then minus, and now we're going to put -1 in. So this would be -1. When I cube -1, I'm going to get -1. So this is going to be plus 1/3. And so this would be 1 minus 1/3 plus 1 minus 1/3. So 1 plus 1 is 2. And this would be minus 2/3. And I'm going to slide it up a little bit. And so I want to get a common denominator. So this would be, I'm going to multiply by 3 over 3. So that gives you 6/3 minus 2/3, which gives you 4/3. And so the correct answer up here is B. All right, go to the next problem. So for this question 22, they're going to let f be the function given by fx equals kx over x squared plus 1. K is going to be a constant. And then for what values of k, if any, is f strictly decreasing on the interval -1 to 1? So we want f to be decreasing on this interval -1 to 1. So that would mean for f to be decreasing on that interval, that would mean the first derivative would need to be negative. Okay, so f is decreasing. Let me write this so I can explain this. F is decreasing on this -1 to 1, right? We want it to be decreasing. That would mean f prime would have to be less than 0 on this interval -1 to 1. Okay, so we need to figure out, okay, what k value causes the first derivative to be negative in here, in that when the x's are between -1 and 1. So what we need to do is find the derivative of this, okay? So to do this, to find the derivative, we're gonna have to apply the quotient rule, okay? So the derivative, and we gotta think of k as being a constant, like 5 or 6 or something like that, okay? So this top, the derivative of the top would just be k times the bottom, which is x squared plus 1, minus the top, so kx, times the derivative of the bottom, which would be 2x plus 0, so just 2x, all over the denominator, which is x squared plus 1 squared. So I'm going to multiply this out, and this would be kx squared plus k, and then minus 2k x squared. Over x squared plus 1 squared. So this kx squared minus 2kx squared would wind up, we can combine these because they're both x squareds. Here we have k minus 2k. That would give us negative k x squared. So my first derivative would be negative k x squared plus the k all over x squared plus 1 squared. Out of this numerator, I'm going to factor out a negative k. And then you're going to be left with x squared minus 1. That's kind of nice because that's a difference of squares, right? So that's x squared plus 1 squared. Okay, so that means f prime of x would equal negative k times x minus 1 times x plus 1 all over x squared plus 1 squared. Okay, so we want this to be negative, right? Okay, so it's going to depend upon the value of k, right? So like, for instance, if k was negative, then that would make this whole thing positive, right? Because we're taking the negative of a negative value, right? But let's use a value in this interval -1 to 1, right? So let's use something like x equals 0, okay? Looking at the bottom here, we're squaring it, right? And so because we're squaring it, this is always going to be positive. Okay, so for that to be, that's always going to be positive in this interval. In fact, outside of the intervals, it'll be positive too. If we plug the 0 in here, right, that's going to give me a negative. And if I plug 0 in here, that's going to give me a positive. So that's going to give me a negative. And then I have this negative out here, negative. So that's going to give me a positive, right? So if k was positive, it would stay positive. But if k was negative, then it would switch back to negative. So again, if I multiply this negative times a positive, that's negative. Times this negative is going to give me a positive. So the only way to make this be the first derivative to be negative is if k would have to be less than 0. Because if k is less than 0, like a negative value, right? Let's say this is -3. Okay, so if this is -3, negative of -3 is +3, right? And then if we plug this 0 in, right, this would be negative, this would be positive, the whole numerator would be negative. So that's the only way to force the whole numerator to be negative, right? Because that's what we need, okay? So the only place that that happens is at a, or when k is less than 0, right? Okay, that's the best way that I have to explain why k would have to be less than 0 for this to work, is just to plug these numbers in and just start trying and seeing and realizing this denominator is always going to be positive. So we don't have to worry about that causing it to be different. All right. So for this one, which of the following is an equation for the line tangent to the graph of y equals 3 minus the integral function -1 to x e to the negative t cubed dt at the point where x equals -1. Okay, so what we need to do to find the equation of a tangent line, we need to figure out what the point is at x equals -1. So at x equals -1, what's the y value, right? So we can get the y value by plugging it in here. So y is equal to 3 minus the integral from -1 to -1, because our x is -1, e to the negative t cubed dt. Well, we should know that if we integrate from -1 to -1, that's 0. So this is 3 minus 0, or 3, right? So this is equal to 3. Okay, so now we have the point. Now what we next need to do is get the slope at x equals -1. To get the slope at x equals -1, we have to take the derivative of this with respect to x. So this would be dy over dx would equal, if we take the derivative of this would be 0, and then minus, so this would be negative, And then to take the derivative of an integral function like this, we're just going to take the x and replace the t. So this is going to be negative e to the negative x cubed. And so we want to find the derivative at x equals -1. So that'd be negative e to the negative of -1 cubed. -1 cubed is -1 times a negative out here is going to be +1. So this is just going to be negative e. And so my equation for my line would be y is equal to my slope, which is negative e, times x minus -1, so x plus 1, and then plus 3. Because I need to shift it to go through this point, right? So I would need to shift it to the left, right? And I would need to shift it up 3. Okay. Now, if you look, this is the way I taught you guys how to write the equation of a tangent line, but they don't have it that way, right? And remember, I've talked about this. All you have to do is move the 3 over to the other side, and we have y minus 3 is equal to negative e times x plus 1. And so the only correct answer would have to be B. So for number 24, which of the following is the solution to the differential equation with initial conditions y of 0 is equal to 3? So what we want to do is do separation of variables. So we know that dy would equal 5y squared dx. I want to get this y squared over on the other side. So I'm going to multiply both sides by 1 over y squared. So 1 over y squared dy would equal 5 dx. Then I want to integrate both sides. And at the same time, I'm going to make this changes to y to the -2 because that will allow me to integrate it easily. And then the integral of 5 dx. And I think I'm running out of ink here. All right, so I'm going to apply the power rule here. So that I'm going to for integrals. So I'm going to add 1 to the power and divide by it. So that's going to be y to the -1 over -1. And then that's going to equal 5x and then plus some constant c. Okay, now this is going to become -1 over y is equal to 5x plus c. And then what I'm going to do is plug in 0 and 3, right? So when x equals 0, y is 3. So this would be -1/3 is equal to 5 times 0 plus c, which tells me that c is equal to -1/3. All right, so now back up here, or back right here at this stage, right? I know that -1 over y is equal to 5x minus 1/3. And then what I'm going to do is I'm going to clear out my fraction. So I'm going to multiply both sides by, let's say -3, or let's just say 3y. So 3y times -1 over y is equal to 3y times 5x minus 1/3. And so this is going to become -3 is equal to 15xy. And then this would be minus y. Okay, and then the next thing you could do over here on this right-hand side to solve, because we need to solve for y, is you could factor out a y. So -3 is equal to y times 15x minus 1. And then divide by the 15x minus 1 both sides, and you'd have -3 over 15x minus 1 is equal to y. Now, there's a problem, right? Because if you look over there, there's no answer that's just like that, right? And if you look, okay, so if you look at this one, what it is, it's going to be this one. So like how you can show that is to multiply both top and bottom by -1. So I'm multiplying by a version of 1, right? -1 over -1 is 1. So that makes the top become 3. And then the bottom is -15x plus 1 is equal to y. Or to match it perfectly, it'd be 3 over 1 minus 15x, which is D. All right, let's go to the next one. So this problem number 25, what you have to realize is that they're giving you the definition of derivative right here. So recall that the definition of derivative, right, the derivative at a point, okay, is, so the f prime of a is equal to f of a plus h minus f of a over h. And I forgot, sorry, this should be here, the limit as h approaches 0. We have to have that, all right? We have to have that for it to be a derivative. Okay, so what you have to do is look at this and go, okay, my a is pi over 3, right? And so what's the function? Well, if you look here, the function is the sine function. So we have f of x is equal to sine of x, and we want to find f prime of pi over 3. That's what this question is asking. As simple as that, right? So what is f prime of x? Well, the derivative of sine x is cosine x. So what's f prime at pi over 3? That would be equal to cosine of pi over 3. So I'm going to draw a diagram for pi over 3. Pi over 3 is in the first quadrant. Opposite pi over 3 is the square root of 3. This would be 1. This would be 2. So cosine would be your x over your r. So this is equal 1/2. So the correct answer is B. So for 26, an object moves along a straight line so that at any point t greater than or equal to 0, its velocity is given by this function. What is the distance traveled by the object from t equals 0 to the first time that it stops? So what we want to do to find the total distance traveled is we want to integrate, okay, from starting at 0 to the first value it stops at, right? So we have to set this velocity equal to 0 to see where it stops, okay? And we have to recall that this t value has to be positive, okay? So we don't even have to worry about negative values at all, okay? So we're going to find v of t is equal to 0. So that means 2 cosine of 3t is equal to 0. Dividing both sides by 2, we get cosine of 3t equals 0. Okay, so where does cosine equal 0? That's what we have to figure out next, right? Okay, so where does cosine equal 0? Well, it's right here and right here. Okay, so that's going to be the first value. So 3t would equal, and so the angle here is pi over 2. And so we're going to then multiply both sides by 1/3, and it's going to be t is equal to pi over 6. Okay, so that means that's the first time it stops. All right, so we're going to integrate from 0 to pi over 6. And it would be the absolute value of 2 cosine of 3t. But what we need to realize is that 2 cosine of 3t, that's going to be positive in this interval from 0 to pi over 6. Okay, so that means we really don't need, and then dt, sorry, we need the dt here. We really don't need the absolute value in this case because it's already positive. Okay, so we only need the absolute value when the function drops below the x-axis. And so from 0 to pi over 6, that's not going to happen here. Okay, because okay, so cosine, if you put pi over 6 for t here, that'd be 3 pi over 6, which is pi over 2. Cosine is 0 at pi over 2, and anything between 0 and pi over 2, then that's going to be positive because the cosine function is above the x-axis. That's what I was trying to explain. Okay, so then we don't need the absolute value, so we're going to change this. So it's 0 to pi over 6, just simply 2 cosine of 3t dt. I'm going to bring my 2 out, and I'm also going to let u equal 3t. So that means du is equal to 3 dt. So I'm going to bring the 2 out, but I'm also going to multiply by 1/3. So this is going to be 2/3 the integral of cosine of 3t times 3 dt from 0 to pi over 6. And so this is going to be cosine of u, and this is going to be my du. So this would equal 2/3 the integral, and this would be cosine u du. And then, so I got to change these two u values. So this is going to be 0, and pi over 6 times 3 is pi over 2. And so the integral of cosine is sine. So this becomes 2/3 sine of u evaluated from 0 to pi over 2. So that's going to be 2/3 times sine of pi over 2 minus sine of 0. And so this is 2/3. Sine of pi over 2 is 1 minus sine of 0 is 0. So this turns out to be just 2/3 times 1, or 2/3. And so the correct answer is C. So for number 27, we have a table that gives selected values for the differentiable and decreasing function f and its derivative. All right. So if this is the inverse function of f, what is the value of the derivative of the inverse function at 2? I really don't like doing calculus with this inverse function notation. So I'm going to change this a little bit. And what I'm going to do is I'm going to let g of x equal to f inverse of x. Okay, so the derivative of this would be the same as g prime of 2. So what we're trying to find is g prime of 2. Okay, now the next thing is, if you don't remember the formula for this, right, if you know the inverse functions, then you know if you put these two functions within each other from pre-calculus, okay, or honors math 3, then you know that it's going to equal x. So in this case, f of g of x, because f and g are inverse functions, that's going to equal x. And so we can take the derivative really quickly of both sides. We can get the formula for the inverse function derivative really quickly, all right? So what this means is, if we take the derivative of this, that'd be the chain rule. So that'd be f prime of g of x times g prime of x. There's our derivative of our inverse function. And then derivative of x is just 1. So that means g prime of x must equal 1 over f prime of g of x. Okay, so if we want to find let me slide it up just a little bit. So if we want to find g prime of 2, that's equal to 1 over f prime of g of 2. Okay, so what is g of 2, right? We got to find that. So g of 2 equals, well, it'd be whatever we put into f to get 2 out. Remember, because they're inverse functions. So for f, we're looking for an output of 2, and it's right here. So we know that f of 1 is equal to 2, which means g of 2 is equal to 1. So that means this is 1 over f prime of 1. And now we can use the table. F prime of 1 is -8. So then that makes this 1 over -8, or -1/8. And so the correct answer is B. So for this problem, the top of a 15-foot ladder rests against a vertical wall and the bottom of the ladder on level ground, as shown above. The ladder is sliding down the wall at a constant rate of 2 feet per second. So we know this is sliding down the wall, right? This is not going to change. The length of the ladder, it's a 15-foot ladder. That's not changing. So we can label that 15 because it's going to stay 15 the whole time. This distance between here and here, I'm going to call x, okay? And that's the horizontal distance. And this vertical distance, I'm going to call from here to here. I'm going to draw it down here. This is y. Okay. And then this would be x. Okay. And so I know that the ladder is sliding down the wall at a constant rate of 2 feet per second. Okay. So that's shrinking, right? And so my that's telling me my dy over dt. And because it's getting smaller, it's decreasing. So it's going to have to be negative 2 feet per second. Okay. And then at what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing at the instant the bottom of the ladder is 9 feet from the base of the wall? Okay. Whew, that's a mouthful, huh? So we're going to want to figure out what this angle is right here, right? So we're trying to find d theta over dt. We're given dy over dt. We're given this angle, or we're not given the angle theta, all right? But we want to relate, because we want to find d. Let me write this. We want to find, sorry, d theta over dt, all right? And we want to find this when x is equal to, when the base, where does it say? When at the instant the bottom of the ladder is 9 feet from the base of the wall. The bottom of the ladder, so that's an x distance. So when x is equal to 9 feet. Okay, so we need a relationship because we have dy over dt and we want to find d theta over dt. We want a relationship with theta and y. So the best for this, I would say, is sine theta. So sine of angle theta is equal to, in this case, y over 15, because that's my hypotenuse. Or sine of theta is equal to 1/15 times y. So now I'm going to take the derivative with respect to time of both sides. And of course, I mean, I know in the actual exam, you'll probably skip, showing all this. Okay, so the derivative of sine theta is cosine theta times d theta over dt is equal to, and then the derivative with respect to time here would be 1/15 dy over dt. Okay, so at this moment, okay, when this happens, my x is 9, right? So what is cosine theta at that moment? Well, cosine theta would be the x, right, over the hypotenuse, right? So in this case, at that moment in time, cosine theta would be 9 over 15. So that means I can replace this with 9 over 15. So I'm going to write 9 over 15 times d theta over dt is equal to 1/15. And then times my dy over dt is -2. So I'm going to multiply both sides by 15 over 9. And that would give me d theta over dt is equal to 15 over 9 times 1 over 15 times -2. So my 15s are going to cancel here. And so my d theta over dt is going to be -2/9. And that should make sense, right? It's going to be negative. Why? Because this is sliding down, right? So this angle is going to be getting smaller. So the correct answer is A. And this is just, this is just a related rates problem, okay? That's all it is. All right? Okay, guys, that's it.